Okay, so we were in the middle of solving this problem here, and we created a present state next state table, and now what we have left to do is generate a state diagram for this finite state machine that we have shown in this circuit diagram here. So I went ahead and I copied this table onto my next notebook page so we can refer to it over here. So here's that present state next state table, and now we need to draw a state diagram. So every state diagram starts with a legend. And so in the legend you put in your state variables, which are y1, y2, at the top of your bubble. You could also have a state name at the top of your bubble, so you could call this like state name, but in this case we're going to list our variables. Now if we had any more outputs, we would put them on this in this section right here and list them, but our Z output is a mealy output, so it's not going to be part of the state bubble. Okay, so then you're going to show transitions here where you're going to have your inputs listed on the top of this slash looking thing. So here I'm going to have input X and output Z. So here is where the more outputs go. The more outputs go over here. I'll go ahead and list that, more outputs. And if we did have any mealy outputs, they would go right there. Okay, so our legend here will consist of telling you what state variables we have, y1, y2, and what our inputs and outputs are. Okay, so in our state diagram, remember we have two state variables, so we can have a possibility of 4 different states. So I'm going to draw the 4 states like this, 4 states, 4 bubbles. The first state is when y1 and y2 are both 0, so I'm going to call it the 0, 0 state. Then we're going to have the 0, 1 state, the 1, 0 state, and the 1, 1 state. Okay, so now we need to say how are we going to get from one state to the next state? Well, if we're currently in 0, 0, that shows us the first 2 rows of our PSNS table. Show us the present state is 0, 0. Now we can go from 0, 0 to the next state, which is 0, 0, when X is a 0 and the output Z will be a 1. So our transition from state 0, 0 to back to itself happens when X is a 0, so we put 0 here on the top of the slash, and our output for that case, Z, is a 1. So we just filled out the first row of this table with this directional arrow. We're going from state 0 back to state 0 when the input is 0, and that gives us a mealy output of a 1. Alright, so now we're going to be going from state 0. Oops, let me go ahead and close this. Now we're going to be going from state 0 to state 0, 1 when X is a 1 and the output will be a 0. So going from state 0, 0 to state 0, 1 when X is a 1, the output is at that transition 0. So this is now the second row of the PSNS table. Now we're going to go from 0, 1 to 1, 0, so we're going to have this arrow, this third row, when X is a 0 and Z is a 0. So this is going to have a 0 slash 0. Fourth row, we're going to go from 0, 1 to state 1, 1 when an X is a 1 and Z is a 0. Fifth row, state 1, 0 to state 1, 0, so it stays at itself when X is 0 and Z is 1. State 1, 0 to state 1, 1 when X is 1 and Z is 0. State 1, 1 to state 1, 1 when X is 0 and Z is 1. And 1, 1 back to 0, 0 when X is 1 and Z is 0. So this completes our entire state diagram showing all the transitions between states. And because we have one external input, we should cover the cases for when x is both a 0 and a 1. So every single state should have at least two arrows leaving it. So you can see state 0, 0 has this arrow leaving it and this arrow leaving it. State 0, 1 has this arrow leaving it and this arrow leaving it. State 1, 1 has this arrow leaving it and this arrow leaving it. And state 1, 0 has this arrow and this arrow. So that's a way to check that you've done everything correctly, is that every state should have the total number of inputs choices leaving the state. So in this case, because we have one input, we have two possibilities of x, so every state should have two transitions leaving the state. Alright, so we have successfully now completed an FSM design problem with a present state, next state table and a state diagram. The next problem we're going to do is going to go in the reverse direction, where we're going to start with a state diagram and have to derive the circuit from that diagram.